Hello everyone, it's Miss Thomas, and today we're going to look at the fundamental theorem of algebra. So the fundamental theorem of algebra states that if p of x is a polynomial with a degree of n greater than 0, then p of x has exactly n roots, including multiple and complex roots. And we've kind of already looked at this, and this is really just the idea that if you're solving something like three x to the fourth plus 6x squared minus 2 equals 0, it is going to have 4 roots because the degree is 4. Similarly, if you're solving something like negative 2x to the third plus 6, it's going to have 3 roots because the degree is 3. So nothing super new. All right, so here we have an example using the fundamental theorem of algebra, and how we're going to use it is basically letting us know that because it's a 4th degree polynomial, I need 4 roots. When I look at this, I first want to think, can I factor it? Believe it or not, factoring is going to be the easiest route to go. So you're going to look for your GCFs. When I look through this entire thing, the x, 4x cubed, x squared, 12x, and the 12, they don't have anything in common. These 4 terms have an x, but this one doesn't. These 3 terms are divisible by 4, but these 2 aren't. So there's no GCF. So then I want to think about my little factoring flow chart. So I've looked at the GCF, then I want to think about how many terms I have. 1, 2, 3, 4, 5 terms. 5 terms. We don't have a method for factoring something with 5 terms. So what I'm going to have to do is use the rational root theorem to generate a list of possible roots and use synthetic division. So since it's not factorable, so as a reminder, that's our p's and our q's, and our p's are the factors of the constant, and our q's are factors of the leading polynomial. I'm just going to put LC for leading coefficient. So factors of my constant is a negative 12. So 1 goes into negative 12, 2 goes into negative 12, 3 goes into negative 12, 4 goes into negative 12, 6 goes into negative 12, and 12 goes into negative 12. So remember, we want to do positive and negative because we really don't know if it was a positive 1 times a negative 12 or vice versa. Thankfully, our leading coefficient is a 1, so that really narrows down our factors of the leading coefficient to plus or minus 1. So then, our P over Q is going to be all the factors of a constant over the factors of our leading coefficient. So that really is just our list of P's, because everything divided by 1 is just going to be the same thing. So now the next step that we need to do is use the remainder theorem and evaluate our function for all of these terms. Do it for the negatives as well. Oops, that should be a 12. Sorry about that, I got a little carried away. 12 and negative 12. So again, we can take our time and slowly punch each one of these values into the expression and evaluate it, or we can just let our calculator do some of that computation work for us by plugging it into the graphing component and letting it grow. So we are going to do y equals x to the fourth minus 4x to the third plus x squared plus 12x minus 12. So it should look like that in your graphing calculator. In your y equals, that's where I entered this. And then all I need to do is hit second to get the table function, and I can find my values in there. So where x equals negative 12, my y is going to be 27,636. And I'll just scroll through and find all those values. So I found all the values that p of x evaluated to for our possible rational roots. And the rational root for this function is going to be 2, because the 2 evaluates to the 0. And so we know that that means that x minus 2 is a linear factor of this polynomial. What we're going to do now is we are going to take the polynomial, since there's only one rational root, take the polynomial, take the factor of the polynomial, and do synthetic division so we can get it down to something smaller. Okay, so I just took the coefficients from the polynomial and my rational root of 2. I'm going to bring down the 1. So then I take 2 times 1, write the product here. I combine down, so I get a negative 2. I'll take 2 times negative 2, write the product here. Combine down, and I'm going to get a negative 3. 2 times negative 3 is going to be a negative 6. Combining down, I am going to get a 6. And 2 times 6 is going to be a positive 12. Combining down, I'm going to get a 0. And as a reminder, that's my remainder, which is why the 2 above p of 2 evaluated to 0. So now that we've divided, let's look at what polynomial we have. Basically, dividing by the 2 is like factoring out an x minus 2. So when we factor out that x minus 2, we're left with x, in this case cubed, minus 2x, minus 2x squared minus 3x plus 6. So we want to see, kind of start the process all over again, which is exhausting, I am aware. So we want to start again, because we're not down to a place where we can just solve this thing. And so we really want to look at this and think, okay, well, is there any way to factor this by grouping? And because we have 4 terms, and that's why I'm factored by grouping, because there's not a GCF. So if I want to just group, that's a negative, so I'm going to put it inside and make that a positive outside. So my first group, x cubed minus 2x squared, I can factor an x squared out of both of those. And when I factor an x squared out of x to the third, I'm left with an x. And if I factor an x squared out of the 2x squared, I am left with a minus 2. Plus, looking at this, 3 goes into both of these terms. Since this is negative, I'm going to need to factor out a negative 3. So negative 3 times an x would give me a negative 3x, and a negative 3 times a negative 2 would give me a positive 6. So as you can see, we do have that GCF of x minus 2. And then our other factor is going to be x squared minus 3. So bringing this factor down, because we need to not forget about things we've factored out. The factors of our original polynomial are x minus 2 times x minus 2 times x squared minus 3. Well, obviously, both x minus 2's are going to lead to a root of a positive 2. This is where that multiplicity comes in. The multiplicity of this is 2 because there's 2 of them. Our x squared minus 3, we're going to need to set separately equal. And solve that. Because it's x squared minus 3, we can just go ahead, add the 3 to both sides. We get x squared equals 3. Taking the square root of both sides, we get x equals plus or minus the square root of 3. So my roots are x equals 2, x equals a positive square root of 3, and x equals a negative square root of 3. So your you-try is to write in your own words what steps need to be taken to find all the roots of the polynomial. And be careful about the your own words portion of that. Please don't let me see the same explanation on you and your friend's paper, because you will never use the same words if you're writing it yourselves. Have a great day. I'll see you tomorrow.